viewers, welcome to video number 64 of channel Chemphilic, and video number 64 is the 6th episode of chemical thermodynamics, and in this 6th episode I will discuss about thermodynamic processes. So let's start. Thermodynamic processes. What does it mean? This process means these are the operation by which system goes from one state to other state. Now these thermodynamic processes are of different types. Now let's see. Isothermal process, adiabatic process, isobaric process, isochoric process, and finally cyclic process. Now let's learn one by one about these processes. Now look at here. Here the liquid is boiling. We know that when the liquid boils, its temperature remains constant. It boils under constant atmospheric pressure and the temperature remains constant. Though it is absorbing heat, that means you are providing heat. Liquid is heated. Why we know? Because the heat absorbed here during boiling, it goes to break the strong intermolecular forces between the liquid molecules so that it can be converted to gas. In the gas molecules, molecules are apart, so intermolecular force of attraction is very low. So the temperature remains constant. This absorbed heat does not increase the temperature. It is utilized to break the strong intermolecular attraction between the liquid molecules. Okay. This process or this boiling is isothermal process. Iso means same. Here thermal means temperature. That means temperature remains same or temperature remains constant. Now see this one. This is reaction taking place in this closed vessel. So it is exothermic reaction. That means heat is released. But this released heat is going to the surrounding. So in the surrounding you have taken the cold water. So the released heat is going to the surrounding. So inside temperature remains constant. So this is the example of isothermal process. Similarly here, it is endothermic. That means during the reaction, the system is absorbing the heat. Absorbing the heat means inside it will become cold, but it takes heat from the surrounding. Say here it is hot water. So it is taking heat from this hot water, that is the surrounding, and inside temperature remains constant. This is the example of isothermal process. So what is isothermal process? A process in which although the heat enters and leaves the system, okay, here heat is leaving the system, leaves from the system, here heat is entering, but the temperature remains constant throughout the process. That means there is no change in temperature, or we can say change in temperature is zero. So in isothermal process, change in temperature is zero. Now coming to this example. See, this is a cylinder which is attached with a piston and inside a gas is there. And these walls are insulated. That means no heat can enter from the surrounding to the system. System is gas and no heat can be released from the system to the surrounding. Okay. Now just imagine initially the piston is here. That means volume is less. That means gas is compressed or under compression. Now this volume expansion takes place. So volume expansion takes place means the gas does some work or some work is done by the gas. So when the work is done by the gas, it needs energy. but there is no source of energy because system is completely insulated. No energy, heat energy can enter from the outside or from the surrounding. Then the gas utilized its own internal energy. Internal energy I will discuss in my next episode. That is the microscopic level of energy, which is the inherent property. So, internal energy decreases during this expansion, and internal energy is function of temperature. So, temperature decreases during this expansion, but no heat enters into the system. So, this is the example of adiabatic process. So here just now what I told, that walls are insulated, piston can move up and down and no heat can enter or leaves the system, and this is adiabatic process. And what is adiabatic process? In adiabatic process, no heat can enter the system or leaves from the system. That means Q is equal to 0. There is no heat exchange. Next, coming to this example. So look at here. This is a gas enclosed in this cylinder, and it is also attached with a piston, which is movable piston. That means piston can move. Now, when the piston is in this static position, or it is in this particular position, that means pressure of the gas which is acting upwards will be equal to the external pressure which is acting downwards. So this downwards pressure on the piston or on the gas, that is the external pressure. This downwards pressure will be the atmospheric pressure as well as this weight of the piston. Right? Now you are supplying some energy. So the gas absorbs energy. But this external pressure is constant. That means atmospheric pressure and weight of the piston, this is constant. So when it absorbs energy, keeping the external pressure constant, then you will come to know in first law of thermodynamics, then the internal energy of the gas increases and this expansion takes place. That means the gas does some work. How? It moves the piston from this position to this position. Thereby expansion or volume expansion takes place. But external pressure is constant. So absorbed gas does this work, moves the piston, whereby volume increases and its internal energy also increases. Okay. So this is the example of process which takes place under constant pressure, and it is known as isobaric process. Here external pressure remains constant, remember. Now say for example, this is another example. This is the boiling of water in an open vessel. The vessel is open and boiling takes place under constant atmospheric pressure. And so this is also the example of a process which takes place under constant pressure. Here it is constant atmospheric pressure. External pressure is atmospheric pressure. So what is isobaric process? Process during which the pressure of the system remains constant throughout. So therefore, for isobaric process, there is no change in this external pressure. So delta P is equal to 0. Now look at here. Here also water is boiled in a closed vessel. So vessel is closed means this volume of the water remains constant. It is boiled. So what is happening? Its vapor will be there. So overall vapor plus water will occupy the volume of this container. That means volume remains constant. This process is known as the isochoric process. That means the process where the volume remains constant. That means in isochoric process where the volume remains constant throughout, there is no change in the volume, so delta V is equal to 0. Now coming to the last one, that is cyclic process. In the cyclic process, the system comes back to the initial state through a number of different processes. So from which state it starts, it comes back to the same state. That means there is no change in any of the thermodynamic properties. No change in temperature because it is coming to the same state. No change in the pressure. No change in the total heat contents or enthalpy. Delta H is equal to 0. Delta U, this is internal energy change. This is also 0. Say for example, this one. This is Carnot cycle. You will learn it later. So here you see, first of all, expansion. This is isothermal expansion. This is pressure volume curve of the gaseous system. First step is the expansion. That is isothermal expansion. Second step also expansion, that is adiabatic expansion. Third step is the compression or contraction, and that is here isothermal contraction. And then again the fourth step also compression, that is adiabatic compression or contraction. So it starts from A, it goes to B, C, D, finally comes back to the same state A. This is cyclic process. Now, another practical example of cyclic process is working of the refrigerator. In the refrigerator, we use that refrigerant. Refrigerant is, say, it is a gas. Generally, you will take the freons, chlorofluorocarbon. Okay. So, this is the system. First, the gas is taken in this compressor. And the compressor means gas gets compressed, so its temperature increases. Now this compressed gas comes to this condenser coil, and after coming to this condenser coil, gas was heated, it releases the heat in this coil and then it becomes the liquid. Now this liquid comes to this expansion valve. This is the expansion valve. It is a cyclic process. Compression, then it has to undergo expansion. So it is the expansion valve, and here expansion takes place. So liquid and vapor, once again they are pulled by the compressor to this evaporator coil, and here in this evaporator coil, this liquid gets evaporated, and for evaporation, it takes the energy from the surrounding. So, the surrounding temperature or freeze temperature decreases. It becomes cool. And once again this after evaporation, vapor goes to this compressor, and again this cyclic process continues. This is the function of the refrigerator, which is the example of cyclic process. So, this is all about different thermodynamic processes. Thank you.